Hello, and welcome to our final presentation for our CS532 semester project. Our chosen topic this semester was analyzing the sentiment in consumer reviews. In this section, we're going to talk about the overview of our design and implementations and go into a few details on how we extracted our results. First, our frameworks and environments. We're using PySpark and Natural Language Toolkit as our Python frameworks that help us process the data and do our natural language processing. Our code was run on Google Cloud servers using the Google Colab environment, and all our data is stored via the Google Drive. The flow of our program is pretty straightforward. First, we pre-process the raw data into a format that our models can interpret. Next, we run this data through the 3 sentiment models, get our sentiment scores, and finally, we can use these results and compile some figures to understand them better.
To begin the pre-processing of our data for sentimental analysis, we follow a series of cleaning steps. First, we load the CSV file containing our data into a PySpark data frame. Next, we filter out incomplete rows, ensuring that we only work with complete and valid data points. After that, we address the issue of special character within the text. We replace this special character to avoid any potential disruption during our analysis. To ensure uniformity, we convert all the text to lowercase. Moving on to stop words, which are words that hold little to no significance in determining the sentiment value of the text. To identify and remove the stop word, we utilize the English stop word index provided by the NLTK library. This index helps us determine which word to exclude from our analysis. To efficiently apply this removal process, we make use of PySpark machine learning function. By applying a stop word removal transformation to our data frame, we can effectively improve the accuracy of our sentimental analysis. English language often contains different word spelling or inflections that convey the same meaning. To consolidate this variation and simplify our analysis, we employ lemmatization or stemming techniques. Lemmatization is a more sophisticated approach, particularly suited for our analysis because verbs play an essential role in determining sentiment. To achieve this, we utilize PySpark user-defined function to apply the NLTK lemmatization to our data frame. By performing this cleaning, stopword removal, and lemmatization step, we ensure that our data is well prepared and optimized for further analysis, enabling us to extract meaningful insight and sentiments from the text.
Okay, so now we're done the pre-processing the data. Now we jump into the processing the data. And firstly, we need to define the sentimental score of a review. So initially, we think about the average sentiment score of each individual words in the sentence. And for the sentimental score of each word, we can get from the pre-trained lexicon table in Vader model of NLTK. And this model basically get the average the score of each word. And the problem with model is the small positive score will affect a lot on the average score, will pull the score down. So we have the second model to resolve that problem, which is the proportional sentimental score model. And the idea behind this is to divide into 2 groups. One is positive words and the second is negative words. Each group will have the weights of the score, which is the absolute total score of the word in the group. And the score will be defined as the total positive score over the total weight of both group. And we also found that the beta model has the built-in sentimental score for the review, so we also test that out. And we have 3 models, and we want to choose what's the best one. And in order to get the best one, we will compare the result of this model with the real ratings. And because the rating and the score is represent in the different scales, so we need to normalize first and compare it. In order to compare the performance, we calculate the residual for each model and plot it out here. As you can see, the 3 plot here. So this is the plot for the residual of each model, and you can see that the second one, which is the proportional sentimental model, has the best performance. This is because it has the most quantity of the zero residual. So we decided to go with the proportional model. And in order to represent the sentimental score over time, we try to plot it in the plot basic sentimental here as I showed you, and it doesn't show any meaning. We cannot get any insight from this, so we decide three other way to represent the sentimental score over time, which is the cumulative average and moving average. So cumulative average is the average sentimental score from the past to the specific date, and the moving average is the average within a fixed window. And as you can see, the cumulative average show which perform better, like it show apparently the downtrend for this product. So we plot the sentimental score over time for every product. Here we have 24 products here, and I will detail to some of them. So the first example I want to show is the graph will have the uptrend. So in here we can say that the producer is doing the good job in the produce this product because the rating is go up over time. Even here is slightly uptrend. And the second one is downtrend. So here you the producer should look into what is the problem of this products. So in order to do that, we need to get the meaning of the review, which is out of the scope of this project. So it should be in the further improvement.
Another goal for this project was to analyze the sentimental differences between products in similar product lines and product families. So to do this, we produce these bar charts that do just that and allow us to compare the different products and the different product lines. One interesting result that we found is that if you look at the Fire tablets at the very bottom of the chart, you see that Fire tablet 8 with the 32 gig is significantly lower on the sentiment score compared to the other Fire tablets, which gives us some sort of information that we can investigate this product to see if there's something unpopular or something different about this one that's causing the lower sentiment.
Our last goal is to test the performance of PySpark. When running parallelism with PySpark, adding more core can initially result in significant time gains, but the rate of improvement diminishes after a certain point. This phenomenon is known as diminishing returns and is a common characteristic of parallel computing. There are several reasons why this slowdown occurs, like communication overhead, limited resource, data dependency, and workload imbalance. But we can't deny the fact that enable parallelism substantially increase our computation time. Adding the graph, adding 4 to 6 core, like decrease the time complexity by almost 70%, which is a huge margin. While the current model results show promising performance, there's room for further improvement through summarizing more results from our model and data. Like the top 10 most popular words for each product, we could use the word to help us define the characteristic of the product and better learn them. Also, we can create pie chart to display the proportion of positive, negative, and neutral words, which is a good data visualization to compare different items or even different similar products across the whole scope. And lastly, we can train a machine learning model that can predict sentiment for other types of review. This helps capture the nuance of the language, and since this is a machine learning model, it has the ability to adapt to new trend in language that otherwise we can do without it.
To conclude, we will briefly recap all the proposed project goals and how we completed them. Our goal to find which sentiment model was accomplished, and our data showed that the proportional model was superior. We were able to produce sentiment over time charts for each product using this proportional model. And we're also able to compare sentiment of the products within the same product lines using the bar graphs. Using the sentiment over time graphs, we can see at a glance how consumer opinion changed for each product. And finally, by limiting the amount of threads in our environment, we can see that the PySpark's multi-threading built-in capabilities provided significant speed up when running this project. Thankfully, we accomplished all our goals and we left none incomplete from our proposal. Thanks for listening.